I got cut off in the multiple choice video, so I'll finish up number 10 here. The correct answer was E. I don't know how much of the N you heard, but it's going to be symmetric here, just not normal. Not normal because my sample size is not big enough, but it will be somewhat symmetric in shape because my outcomes here, I'm either going to have $40 or $80. So if I average, I'm only ever going to get either an average of 40, of 80, or right in the middle, 60, if you think about it. Like if I take 2 weeks and they're both 40, that's going to average to 40. If I take both weeks and they're 80, that's going to average to 80. If I take both weeks and they're one of each, they're going to average to 60. So I'm only going to have 3 outcomes here. So it will be symmetric, just we can't say it's going to be normal. Now let's move into the FRQs, and I'll type for these just so you can read a little bit better. Below are histograms, the values taken by 3 sample statistics and several hundred samples from the same population. The true value of the population parameter is marked with an arrow on each histogram. Which statistic would provide the best estimate of the parameter? Justify your answer. So if you remember those targets I showed you in the notes, I can actually go back to them. But in the very beginning, we talked about what it means to be unbiased or biased and what it means to be high variability or low variability. And we said this last target was the best. If you're hitting the bullseye and all of your darts or whatever your target, you're hitting the close together in the bullseye, that's our best case scenario. That means we have low bias, we're hitting the target, and low variability, we're tight, packed closely together. So if I go back to this problem, they all seem to be decent bias-wise, right? They're kind of measuring what they're supposed to. This one's a little bit too skewed, so C is the worst one. It is a little bit skewed to the right, meaning it's not necessarily hitting the target that we want. We're not centered. But these two, A and B, are very centered, but A is better. A is the best here because, one, it's hitting the target. My true population parameter is in the center of the distribution, and its variability is the least of all 3. So it's low bias, low variability. A is the best statistic. All right, question 12. The amount that households pay service provider to internet varies quite a bit, but the mean monthly fee is $28. So mu is $28, and the standard deviation, sigma, is $10. Let me write that down before I forget it. The distribution is not normal. That's important. Many households pay about $10 for unlimited dial-up or about $30 for unlimited dial-up, but some pay much more for faster connections. A simple survey asks an SRS of 500. So N equals 500. Let X bar be the mean amount paid. Explain why you can't determine the probability of the amount of one randomly selected household pays for access to the internet exceeds $29. I can't find this probability because I'm not told anything about the distribution. I'm told specifically it's not normal, so that means norm CDF's out. And I really don't have anything else to work with, so I can't find that probability. However, for the sampling distribution, the mean of that sampling distribution is the same as the population mean, so 28. And the standard deviation, I apologize for my writing here, the standard deviation of all the X bars, or the sampling distribution, is the population standard deviation divided by the square root of N. So whatever we get for that, I'll make it a decimal in a second. Oh, wow. What is the shape? That means check the normal condition. And the normal condition for means is the sample size has to be greater than or equal to 30. And here it is. So C, you would just say this shape is normal because N is greater than or equal to 30. Find the probability that the average fee paid exceeds $29. So because I said normal in part C, I can find this probability. So here's my mean at 28. 29 is somewhere to the right. And I want more, so I'm going to shade to the right. So you would go to your calculator and do norm CDF of this, lower bound 29, upper bound infinity. This is my mean and my standard deviations, whatever decimal I get there. So let's see what I get. 10 divided by square root of 500. So there's my standard deviation, 0.447. So I go to menu, probability distributions, norm CDF, 29 to George Sink, and my mean was 28, and I just found the standard deviation was 0.447. So I click OK, and there is the probability that I get a sample mean of $29 or greater. 13, now we're about proportions because I see percents. According to government data, 22% of American children under the age of 6 live in households with incomes less than the poverty level. So that's my population proportion P. It'll be 0.22. A study of learning early childhood, choose an SRS of 300, so it's going to be N. Find the probability that more than 20% of the sample are from poverty households. Or find the probability that more than 20% are from a poverty of households. So I'm interested in P hats greater than 0.2. We're going to find that probability. So let's go check my conditions. I'm just going to kind of check them out loud. I'll go back to my notes here. So for normal, condition for proportions, I'm going to do NP and NQ. So for this sample size was 300 times 0.22. $66, that's bigger than 10. And times 0.78. I get 234, so I'm definitely satisfying that normal condition. And then my other condition, the 10% condition, 300 children is less than all American children, less than 10% of all American children for sure. So I met those conditions. To find this probability, I'm going to use the mean of the sample P hats is the same as the population proportion, so 0.22. The standard deviation of all the P hats, that's the square root of PQ over N. So here it's going to be the square root of 0.22 times 0.78 divided by 300, 0.024. Sketch my normal curve. There's my 0.22. Let me double check. I want the probability that more than 20%. So 20%'s over here. And more means my shading is above. I'm going to shade all this. Lovely shading. So I got a norm CDF menu. I'm going to do 0.2. So George Sink. My mean was, I forget, 0.22. And my standard deviation was 0.024. Or sorry, 024. And I click OK. I get 0.798. Is the probability that more than 20% of children in one of these samples is from poverty households. All right, hope that helps with the review. You'll have your Chapter 7 quiz your next in-person day.